Good afternoon. My name is Rico Robinson, and this is yet another addition to my video portfolio within my resume in an attempt to show recruiters and staff members alike that I have the hard skills and knowledge to participate in the cybersecurity job industry. In this particular demonstration, we're going to be showcasing Snort. More specifically, we're going to be creating a couple of basic rules, deploying Snort, and then getting one of our VMs to fire those rules. So this is going to be a brief and to the point presentation. Let me just preface and say that if if you're a recruiter or a staff member and you want a more extensive presentation or you want to interview, please reach out to me. My contact information is on my resume, and chances are, if you're looking at this video, chances are you got here via a link from my resume. So let's go ahead and get started. Just to give a little context, there's two VMs here. One on the left is a Windows 10 VM that's especially configured to analyze, detonate, and reverse engineer malware. That's on the left. On the right, we have a Linux distro called Remnux that I use with my malware analysis VM on the left. The VM on the right, the Linux distro, is going to have Snort installed, and we're going to use the machine on the left to trigger the Snort alerts. So let's get started by going into the local.rules file. The local.rules file is an integral configuration file for Snort. And this is where you're going to create your rules and add rules, whether you create them or get them off the internet from an open source or get them from a subscribed service. These are where your rules are going to actually go. So we're going to open up that file, create a couple rules, and then we'll save that file, and then we'll test fire a few alerts. So let's go ahead and get started there. We're going to do a sudo vim command. Vim is just basically a rudimentary text editor that's commonly found on Linux and Unix distros. Now I'm going to go ahead and create the framework of the syntax here. The syntax is pretty easy to understand, but I may go a bit silent while I'm concentrating on typing. So bear with me. I'll explain everything once the alert is typed out, or at least the framework of the alert. So we're going to start by activating insert mode here. Okay, TCP. Almost done here, bear with me. Okay. So gotta add a few touches here. Okay, so this is the basis of this is like the framework of the alert itself. I still have to add in a few things, but let me explain what I have so far. So basically every Snort rule is split up into two parts. The first is the header, and that's basically everything up until the opening parentheses. And then everything after would be, it's called different things, but I learned it as it being called options. Basically, it's the second part of the Snort rule, and that has basically the meat and potatoes, if you will. It's going to have string information. It can have regex. It can have any content you want Snort to actually use to detect the alert that you're trying to discover or uncover, if you will. So for the first, let me go over the alert and the syntax that I have here. We have alert, which is basically the first word of your Snort alert will be the action that you want Snort to take. So you have a few options you can take. You can ask for Snort to alert you, basically send an alert to the interface that you're using, that you have an analyst viewing. You can task Snort to actually drop the packet or even drop the connection. This might be actions that you would take if Snort was actually in line, i.e., if Snort was actually an IPS rather than an IDS. But you want to be wary on how you want to do that. If you're going to put a Snort device in line, you want to make sure you're not dropping any legit traffic, which can definitely be a problem that can happen in the real world. But anyway, we have it set to alert here. The protocol is TCP. The different protocols you can choose is TCP, UDP, ICMP, and there's a few rare options you can choose, like such as SSL, HTTP, DNS, so on and so forth. This is going to be a connection-based protocol, so we're going to use TCP. External net is basically the attacking device or the offending device. In this case, it's going to be the left VM. And then you're supposed to list the port number right after that. In this case, it doesn't matter what port number it is when it's coming from the attacking device. So we're going to put any. We're going to put the direction of the proposed flow of traffic. In this case, it's coming from the internet. It's going to our internal network. And where it says home net, that's the representation of an internal network. That can either be it could be either an IP address, or you can make it to where it's a subnet. In this case, when we say home net, it's going to be the subnet of our local network. In this case, the two VMs are on the same local subnet. So that subnet is configured to be the home net that you see here. In this case, the subnet for this VM is 10.0.0.0/24. So when I type in home net, it's going to represent that particular subnet. This is going to be a web-based alert. So we're going to put port 80 here. And then in our options aspect of this Snort alert, we're going to have the message, which is going to be the string. This is going to be a mock malware callback alert or callback attempt. So in this case, we're going to put our domain here, our offending domain. In this case, it's going to be google.com. And yes, we know Google is not an offensive website. This is just a placeholder. In the real world environment, you would put a malicious domain here. So this is just a placeholder. Content-wise, we're going to put... Oh, excuse me. I messed up here. Sorry. Bad mistake. On content, we're going to put google.com. And then on message is going to be the name of our alert. In this case, it's going to be callback attempt. Okay. And then moving on to the next part of the alert. Give me a second here. Okay, here we go. For the SID, that's a Snort ID. The Snort ID can be an array of different numbers. You can use any numbering convention you want. You just want to make sure there are no conflicting or any SIDs that will collide with each other, i.e. two alerts with the same SID. You want to avoid that as much as possible. With that said, you can name it anything you want for the sake of simplicity. We're just going to call this SID1. And then revision is just your revision of the alert. And I'm always going to put 1 there unless, I actually revise the alert and keep track of that. So now this is our first alert. We're going to go ahead and make our second one really quick. Excuse me if I seem a bit rushed. I'm trying to keep this video under 10 minutes. And this is going to be our ICMP based alert. This is basically going to look for ping traffic. Nothing more, nothing less. And since this is ICMP based traffic, port numbers aren't going to matter. Let's see. This ping test. SID2. I'm missing something here. Oh, yeah, there we go. Okay. Okay. All right, so this is going to be our ICMP ping test alert. This is going to look for ping traffic coming from the external net. Excuse me. Other than that, I think everything is fine here. I just want to look over the rule real quick, make sure our syntax is sound here. Give me a quick second, bear with me. Okay, we're good to go. Looks like we're good to go here. Wait a minute. Okay, all right, we're good to go here. Let's go ahead and save. Okay, we're going to start something called iNetSim here. I don't have all the time in the world to explain how this works, but basically iNetSim is going to simulate a fake proxy server, if you will. It's going to capture all the HTTP traffic, or basically all internet traffic from the VM on the left here. So we're going to run that real quick. We're going to go ahead and deploy Snort. I don't, I'm not going to go through the hassle of creating the Snort deployment command by scratch, because it's a very long command. But just all you should know is that Snort is officially deployed right now, and it is active, and it's going to look for, it's going to capture traffic coming from this machine on the left here. So let me do a quick IP config here. So this machine is a .4, a 10.0.0.4. That means this machine must be a 10.0.0.3. Okay, so these two machines are on the same local host network, virtual local host network, which basically means these two machines can talk to each other, but they cannot communicate outbound. So we're going to again, just to go over the semantics here. The left machine is going to be the offending machine. It's going to trigger the traffic, and then the right machine is going to capture it with Snort. So let's go ahead and give it a try here. Let's go ahead and try to access google.com from the VM on the left. There we go. Took a while, but we went ahead and did a Google request, or HTTP request to google.com, and it did trigger the malware callback attempt alerts. Now, again, this is just experimental alert. Of course, you would replace this with a more malicious domain, and you might even want to add certain other indicators of compromise that can be found in the captured packets to make this alert more robust and less likely to trigger a false alarm. Now we're going to go ahead and trigger the ping test alert by pinging the next machine. Since this is a .4 address, that means the other machine is a .3. So let's do a 10.0.0.3. There we go. And as you can see here, Snort is capturing the ping traffic in real time. So, that's basically Snort in action. I don't want to go any further than that. I'm probably already made this video longer than I would like to. But let me just say again, let me reiterate, if you're a recruiter or a team member watching this video and you want to do an interview, please reach out to me. My number is on my number is on my resume, and I would love to bring my skills to the table. I believe having the ability to create Snort syntax can be a great asset as a threat analyst. Thank you, and have a nice day. And thank you for watching this video.